Hello and welcome to the Kuyumungi Institute, our Q&A Conversation for Exploration series. I'm Paul Robear, the Executive Director and President of the Institute, and along with my wife, Laura Lee, the Director of Research, Education, and Outreach, we want to thank you for joining us today. The Kuyumungi Institute is an independent, nonprofit anthropological research organization with our focus on the study of consciousness, inspired by the groundbreaking work of our founder, anthropologist Dr. Felicitas Goodman. As an educational institution, we recognize to thrive, we must take an open approach. We saw a need for a unifying framework for further understanding our work here, so in this forum, we're inviting scholars of parallel research in related fields to help broaden the scope. We've had discussions on neuroscience, anthropology, archaeology, archaeoastronomy, cosmology, evolutionary biology, bioacoustics, ethnomusicology, art history, wisdom traditions, mythology, and a bunch more. This has really become a real exciting journey for us of exploration. So today, let's talk about water. Water is the most important substance in this world. I mean, it makes up about 80% of our blood, 75% of our brain, 90% of our lungs. Overall, our bodies are about 70%. So you can live about a month without food, but only about a week without water. Considering its role, there's so much more about water we should know. Today's guest shares revolutionary secrets on the nature of water with profound implications for our health, the origins of life, new technologies, and much, much more. Today's guest will tell us how we're just skimming the surface when it comes to water and its secrets. So Laura, I'm going to turn it over to you to introduce today's special guest.
I first read The Fourth Phase of Water Beyond Solid, Liquid, and Vapor when our friend Gary Hawkins, who builds Tesla coils in Seattle, first handed it to me, and he said, "You're going to love this book." And indeed I did. It spoke to the seemingly miraculous design of our life-supporting universe, as though our universe conspires to create life, and as a natural byproduct, not as a fluke. The implications are just stunning, and you wonder, how could this quality of water, that when it is in touch with living tissue, it resorts itself on its own. It restructures itself to create this fourth phase, a gel-like substances with dramatically different properties that it can hold an electrical charge. Think of the implications. So then I knew, one day I will get hold of this scientist. Here I am, many years later, and I will get to ask him all the questions that I have about subtle energies, about life, about the universe, and also to applaud him for discovering a hidden law of nature. How many scientists are daring enough, we have several in the room with us, to follow where the evidence leads, even though it may bump up against against our worldview and its rather sometimes limiting parameters. So it's just a sheer joy to invite Dr. Gerald Pollack, he says to call him Jerry, here today. He is a world-renowned scientist, professor of bioengineering, head of the Pollack Lab at the University of Washington. That's my alma mater. His fundamental discoveries have inspired several new technologies, even a spin-off company, which he calls Fourth Phase Inc., to bring them to fruition. His books include Muscles and Molecules, uncovering the principles of biological motion, also Cells, Gels, and the Engines of Life. Welcome, Jerry. Thanks for joining us.
Thank you, Laura. Thank you so much for that beautiful introduction. I really appreciate it. And, let me just make one remark before your first question. We always think of the percentage of water that makes up our body. And various numbers are given, 70%, 80%, 60%. It declines with age. But one of the interesting things is that those numbers are based on volume. So the volume of our body, 70% of the volume, for example, 70% is water. But if you do a count of molecules, in other words, you line up all the molecules in your body and start counting them one by one, do you know what percentage of those molecules are water molecules?
Probably
Rhetorical question.
far greater, right?
Far greater, because they're really small, and to make up that 70%, you need a whole lot of water molecules. If you do the count, I haven't, but my colleagues have. It turns out that more than 99 out of 100 molecules in your body are water molecules. It's really so fascinating because modern concepts that you would read in the textbook, modern concepts of about water. Water is, if you read a textbook on physiology or biochemistry, water is merely the background carrier of the more important molecules of life. It doesn't do very much. It's like, the water that fills your bathtub. It doesn't. However, I believe the real truth is that water plays an absolutely central role in everything that the body does. And that the book that you mentioned, the second book, The Cells, Gels, and the Engines of Life, which is now about 20 years old, it describes the evidence for that. And I think the evidence is voluminous. It's mostly not evidence from our laboratory, but evidence culled from so many studies, which indicate that those 99 out of 100 molecules don't just sit there idly. They're absolutely deeply involved in everything that the body does. So I'll end my speech there. I just wanted to mention that you tempted me to do so. Okay.
Your research continues, and you were just telling me about 3 new books that you are about to release that even further explore this miracle. But let's go back to your discovery, because one of the things we love to do is hear, how does someone break through and discover new laws of physics, new qualities of something as ubiquitous as water? What was that discovery process for you? And what did exactly you discover? You say water goes from H2O to H3O2. So it just likes to rearrange itself with living tissue or with hydrophilic substances. What is that discovery? How did you get there? Why wasn't it discovered long before?
It was discovered long before, but not the details of it. More than 100 years ago, some prominent physical chemists were thinking, we can't explain all the interesting features of water with only 3 phases, the solid, liquid, and vapor. And so the idea that maybe there's a 4th phase is 100 years old. It's not new with us.
It was intuited, but not verified.
Intuitive, right, but not verified. Exactly. And then came several scientists who went beyond intuition and were able to find evidence that the water, the biological water, the water inside our bodies, is not ordinary this stuff here that we drink and should be drinking a lot more. But
cheers. Cheers.
Cheers. Yeah, it's my prop. And one of those was Albert St. Georgi. And St. Georgi, by the way, he was no saint. It's S-Z-E-N-T. And if you read his biography, you'll find that indeed he was not a saint by any means, but he was brilliant. And he knew that water was absolutely essential for everything the body does. And there are many famous quotes that come from St. Georgi. My favorite one, which is not this one, is discovery, about discovery. Discovery is seeing what everybody else has seen, but thinking what nobody else has thought. It's beautiful. I love it. It's pithy and right on. But the one that's relevant to water is, he said, quote, life is water dancing to the tune of solids. So he knew, it's beautiful. He knew that water was absolutely central. And St. Georgi was, was no sort of ordinary scientist. He won a Nobel Prize for discovering vitamin C. And many scientists consider him the father of modern biochemistry. Just an absolutely brilliant guy. And then there was Gilbert Ling. Gilbert passed recently, just shy of 100 years old. And probably Gilbert Ling contributed more than anybody to the idea that the water, especially water inside the cell, was so-called structured or ordered. Or we use different terms right now. I'll get to that, but the idea that the water inside the cell was not like water in the glass, and Gilbert was able to obtain a lot of experimental evidence. Just a little bit of background: Gilbert Ling came from China. He was in the first cohort of people after World War II coming to the U.S. from China. They looked all over China and they picked the three most promising scholars: one in physics, one in chemistry, one in biology. The physics guy went on to win a Nobel Prize, and he became famous not so much for his Nobel Prize, but for the fact that when he was approaching 90 years old, he married his 31-year-old translator. And so there's a lot. I'm well connected to people in China, and there was a lot of discussion, mostly about that rather than his Nobel Prize. Anyway, they all thought Gilbert was the cleverest of all, and so we're talking about someone with a real measure of brilliance. And Gilbert was not popular because his ideas challenged the ideas, the common ideas. You know, that water in the cell is just like any old water, and that is still the prevailing view. However, you know, if you cut yourself, the water doesn't come pouring out. If it were liquid, like liquid in the glass that I just raised, you cut yourself, and unfortunately, you will lose your water. You'll dehydrate, and that doesn't happen. You know that the water doesn't when you cut yourself doesn't emerge in the same way as would happen if I poured the glass, turned it over. So it's somehow different. And Gilbert had distinct ideas. Anyway, I'm deviating from your question, but that background is part of my answer to your question, because I'd heard about Gilbert Ling when I was a graduate student. It turned out that in my department, the chair of the department had been studying water. And at that time, boy, I got to tell you, it was the most boring subject imaginable. I had no interest in it. They were talking about so-called bound water. It seemed pretty esoteric to me. But however, that so-called bound water, meaning the water bound to the solids, is exactly what we began studying later. It's just by different terms. Anyway, there was a dinner, and I distinctly remember it was a great big dinner. I can't remember the reason for the dinner, but one of my fellow graduate students sitting next to me taps me on the shoulder and said, "You know see that guy sitting 3 tables away, that Chinese guy? That's Gilbert Ling. He has this weird idea about water inside the cell." And I said, "Okay, very interesting." So that was my first encounter. And then 30 years later, after a career studying muscles and how muscles contract, which was my initial field, and we were deeply immersed in that. And I got an invitation from a colleague of mine to attend a conference in Hungary. And the conference was to celebrate the life of a famous biophysicist, a guy named Ernst, who worked in Budapest or Pécs, I forget which city, anywhere, a Hungarian city. And he had 2 areas of interest. One was muscle and one was water. And I was called on to represent muscle because that was my field. And Gilbert Ling was called upon to represent the field of water because Ernst had been interested in the subject. And along with Gilbert were a cadre of maybe a dozen people who had evidence to support the ideas of Gilbert Ling. So I went my merry way to that conference, and it was eye-opening for me because I had a chance to begin to chat with this guy, Gilbert Ling, who was famous slash infamous. And I must admit, I was so impressed. Uh, it's not that you chatted with Gilbert Ling. He chatted with you. You kept your lips sealed. He liked to talk, but there was less in the way of listening, which I think was maybe part of the personality issue that tended to push him away from various colleagues. Uh, um, Despite his brilliance, he had many enemies, to put it mildly. Anyway, I came back from that conference with my head spinning. I was thinking, if it's really true, what Gilbert Ling is talking about, it's so absolutely fundamental, and I was totally inspired to begin pursuing that, to move away from the area of muscle contraction. We we'd done so many experiments, and I thought I knew the answers, although the world didn't necessarily agree about how muscle contraction works. I had a formidable opponent who was Sir Andrew Huxley, and Huxley came from the famous and distinguished Huxley family, and he was the only one in the family to have won a Nobel Prize. And when he walked into the room, there was a hush. You know, like it was like God walked into the room. And, you know, and when you have an opponent like that, it's difficult to make inroads. So you mentioned the book that I wrote, and the book describes how what I think is wrong with the current view, which has not changed a whole lot in many years, and what I think is right. And so it was time anyway to move on.
You heard a new call to adventure. Yeah.
You might call it that way, and a new call. And so I gave one of Gilbert's books to a few of my students, and they came back to me, and everyone said, "This is so interesting," even though it was not so easy for them to penetrate Gilbert's writing. Gilbert had a tendency to sit down at the typewriter before there was a word processor, even a word processor, bat something out, and that was the book. And it's easy for him, but it was not so easy, and still is not so easy for the readers to penetrate. And so after my students came back to me saying, you know, this is potentially so earth-shaking, it's so central to everything in nature, even beyond life, I couldn't resist. And so I started the lab doing research on water. And please don't tell the National Institutes of Health, but I used the money that they gave me to study muscle contraction to start studying water. But the first thing I did was to write a book, because I thought that Gilbert Ling's ideas were so powerful, so interesting, not only his ideas, but the ideas of people before him, that I wrote that book, Cells, Gels, and the Engines of Life. And the idea initially was to basically explain Gilbert Ling's point of view and the evidence underlying it. But you know, being a person who does think every now and then, I began going a little bit beyond Gilbert Ling, and Gilbert was extremely unhappy. And he expressed his unhappiness to me very clearly in an email, telling me that, first of all, I hadn't quoted him enough. He wanted me to mention his name on every page. I thought I had, but he was angry. And also the idea that the interior of the cell was like a gel. He said, no, that's completely wrong. And he sent this email, CC, to everybody in the field. You know, it's not the sort of endearing thing that one does, but that was Gilbert Ling. And I must admit, I spent the better part of the next couple of decades currying his favor, trying to be friends, despite, and it worked. I finally we did become friends, and I was so saddened to hear is death. Anyway, that's how we got
I'm just glad
started.
that you wrote The Fourth Phase of Water, a book for the general audience, because I don't think I could have read the other one. So, but thank you for making it accessible to your average reader.
Oh, well,
With that.
thank you. I think the first book is also accessible to many readers. That was my goal, to make the science really clear so that anybody could read it and decide whether they thought it was reasonable or unreasonable.
It just hits you between the eyes that it just makes so much sense. Tell us what your basic premise is. Tell us why water would behave differently around living tissue, and then you find that just Earth herself has many situations to structure water. Tell us what you found.
Yeah, and I think the answer is that whatever exists in a living cell also exists outside the living cell, and so it's easy to extrapolate, and there's lots of evidence that shows that the kind of water structure that we're talking about exists throughout nature. It's not just inside the body, it's also outside the body. So let me explain
Even more exciting.
what we found. Yeah, we found that if you have, let's say you have a container full of water and you immerse a solid into it, and the solid has a surface, obviously, the surface interfaces with the water. And if the surface is, I should say, a special kind of surface, because most surfaces are like that, hydrophilic, water loving, which means if it were in a horizontal position and you drop some water, the water spreads out. It doesn't bead up like Teflon. If you have such a surface, most, not all, most such surfaces, when they interface with water, something magical happens. What happens is the first molecular layer of water undergoes a transition. And the transition is from ordinary liquid water, that is the same molecules as in the glass of water, and each molecule is bouncing around at a fierce number of times per second or per femtosecond even, randomly oriented, into this hexagonal sheet-like structure. That's the H3O2.
Crystalline structure, really.
Crystalline structure,
Ordered
exactly.
lattice. Yeah.
Exactly, ordered lattice. That's the first molecular layer. And then what happens is that first molecular layer serves as the template for the structuring of the next layer. And so you get another honeycomb hexagonal layer, and they keep building one by one. So in that process, the water is transforming itself from ordinary liquid water to something that is another state or another phase, however you'd like to call it. We call it fourth phase of water, because the other phases are liquid, solid, vapor. This is a fourth. It's distinct from any of those. We also call it exclusion zone. We started that early on. EZ for short, which is easy to remember, and at least here, but where it's called EZ in Europe and other places, it doesn't work. Anyway, exclusion zone. Why is it exclusion? Because, as you said, it's a crystal, and crystals tend to exclude most everything when they build. So like a glacier, for example, the ice builds, and beyond, at the foot of the glacier, you can see the glacial moraine, all the stuff that's pushed out as the ice crystals grow. And these crystals, they're not ice crystals, but they're not so different in structure from ice. And as they grow, they push out essentially everything. They exclude. So we call it exclusion zone, or EZ. So if I refer to it as EZ water or fourth phase water, it's essentially the same. It's just different lingo for the.
And it has a gel-like consistency because the molecules of the hydrogen and the oxygen are packed differently. You're saying that the molecule grows bigger. It's, 3 hydrogens to 2 oxygen instead of 2. Yeah. So how does that work? It structures itself. Why? What causes it to rearrange?
It's electrostatic, essentially, because the oxygens are negatively charged and the hydrogens are positively charged. So the first, let's say, molecular layer consists of an array of hydrogen, an array of negative and positive charges. The second layer is exactly the same. However, it's shifted by half of the molecular repeat. So wherever you have negatives here, you're going to have positives. The honeycombs are shifted so that when you have a plus here, you have a minus here in the stick.
Like
and that's what confers the gel-like character. So, if you think about Jell-O or think about raw egg white, for example,
it holds together.
Yeah, you can displace it a little bit, but it will bounce back. And it's the same with these sheets. If you displace one from the other a little bit, just a little bit, still those charges are attracting one another. It'll come back to the original. But if you displace it too much, just like a raw egg white, it won't come back. So it has exactly
like a liquid crystal then.
It's a liquid crystal that has gel-like characteristics.
Oh my.
And the idea that the cell is a gel is 70 years old. There's a famous scientist, his name is Fry Gusling, who wrote a book about it, that the cell is a gel with massive evidence. So I think there's not much question. But let me just go on with a couple of more things about this kind of water that grows next to hydrophilic surfaces. So one of the things is that surprised us, water is neutral. But this stuff is negatively charged, it's simply that if you look at the molecular structure and count the number of negatives and positives, the negatives outweigh the positives. So H3O2 is net negative charge because if you wanted something neutral, it would be H4O2, which is double H2O. Both of them would be neutral. It is not neutral, and is based on evidence. It's not just a speculation. We used tiny micro electrodes, parenthetically invented by the same Gilbert Lynn, for which he should have won a Nobel Prize, but he was too controversial to do that. Many investigators have used those tiny glass micro electrodes that come to a sharp point. The tip is less than 1 micrometer, and you can stick these electrodes into cells and measure the electrical potential difference between the inside and the outside. It revolutionized cell biology. Now, unfortunately, Gilbert's name is forgotten in that context, and the people who came after him, who used that technology, won Nobel Prizes galore. But he failed to do so. And I think probably because of the controversial nature of what he had to propose. So anyway, this easy water, fourth phase water, turns out, nobody knew it before, to be negatively charged. And the water beyond, you've got these layers that grow, you've got negative charge, and the water beyond is positively charged. So you've got a battery, negative, positive, that is separated from one another.
And isn't that exciting? Isn't that stunning?
Yes, it's so exciting because
you've got channels, you've got flow, you've got direction, you've got exchange, you've got life going.
The poetry from your mouth is beautiful. Maybe you could edit my next book for me. It is truly beautiful. Yeah, you have all of the above. So many things can happen. It's sort of like your cell phone battery. It powers so much. Without it, your phone won't work. I think I'm the last person on the face of the earth who has no cell phone for various reasons. But at any rate, it's a battery. And so inside your body, you've got electrical energy. It doesn't take a rocket scientist to think that, oh boy, you've got electrical energy inside your body. Maybe this electrical energy is actually used to power some, at least, of what goes on inside the body.
And it's self-generating.
Well, okay, that's another point. Self-generating is maybe one way of putting it, but I guess I wouldn't put it that way. I would put it, what we found experimentally is that the energy, just like the energy for charging your cell phone battery. You know, you plug it
You
into
need to
this.
reamp it.
Yeah,
It
you
spends the
need
energy and it needs more. I get that.
you got some energy that's got to come in to recharge the battery, or charge the battery.
I mean, it created itself. You didn't have to try. It just did it.
Well, it did it, and it does it, and still does it, even today, even this hour. But it does it because it has a constant supply of energy. So where's that energy come from? And I must tell you, in all due humility or embarrassment, that we spent several years, and we couldn't figure it out. It was finally an undergraduate student working in my lab. We have many who discovered it was so simple. He had a light. He was working there. There was a chamber where he was showing next to some hydrophilic surface. You could see the exclusion zone growing. And there happened to be a lamp, a gooseneck lamp sitting right next to him. You know, being curious, he took the lamp and shined it on the chamber. And where he was shining the light, the exclusion zone grew wildly. And he called me in. I said, "Hey, look at this." And I was totally amazed because, you know, it was so obvious. It's light. And we think, well, the light is not always there, but actually it is always there, because we found later that the kind of light is infrared light, beyond the visible. That is at wavelengths that we can't see, but it's right just beyond the red wavelength, infrared. And infrared was, when we did the more systematic studies, looking at visible wavelengths, ultraviolet, infrared. The infrared was something like 1,000 times more powerful than other wavelengths. And we found, using very weak infrared sources, even extremely weak LED sources, that we could grow the exclusion zone by 10 times just by adding more infrared light. So that energy,
infrared sauna and get a big dose.
Yeah, you got it exactly. The infrared sauna is full of infrared light. We feel it as heat, infrared, not quite the same, but almost the same. And that's why when you walk into a sauna, expose yourself to it, you come out feeling better, because it builds easy water. The easy water fills your cells. It needs to fill your cells in order for those cells to do what they need to do. And if you're deficient, you go into the sauna. The sauna should build, because there's infrared, should build easy water. Easy water grows and then refills, so to speak, your cells. And those cells, if they're brain cells, you feel better. You feel alert, alive, happy, the way you should feel, the default state, not depressed. Your muscles are aching, they feel better, et cetera, et cetera. So,
okay, let me correct myself. So it's self-generating in the sense that the entire cosmos has arranged it so that the flow of life, the sun shining on the planet, everything's there for life to flow. That's what I mean.
That's a beautiful way of putting it. I once again invite you to edit my next book. Brilliant. This is such a wonderfully poetic way of putting it. It's true. The sun gives us everything. It gives us, it's not just that we can see when the sunlight, but
if you look at the whole system in itself, yeah.
Precisely, the entire system. And it's the infrared, it's the heat that we feel from the sun that is actually driving us and the world outside through water, through the buildup of this kind of energy in water, the electrical energy, which we then use.
You say that it's the first step of photosynthesis that our cells also do, that you are comparing us to the engines of plants, at least with this first step. Could you describe that?
Yeah, okay. So photosynthesis is a complicated process involving, I think, 20 steps approximately. I've forgotten how many, but many, many steps. And the first step is the sun. We all know that. The sun hits the green plant, let's say, same in some bacteria, other unicellular organisms. And what happens? Well, what happens is the water molecule gets split into H plus and OH minus. That's step one. Uh, it's exactly the same as what I've tried to relate to you. And building the easy water, the raw material is water, H2O, and what happens is that the water molecule gets split, same way as the first step of photosynthesis, into OH minus and H plus. And those OH minuses go on to build the easy water, or the fourth phase water, and that's why the water is negative.
Gotcha.
And the H pluses are the ones that are pushed out into the water beyond the easy layers. See, so in that sense, the process that we've discovered resembles the first step of photosynthesis. And if I may speculate beyond, it's possible that the first step of photosynthesis is actually the same as what we've discovered. It's just that the scientists pursuing that have not come upon the finding. But nature is pretty conservative, and nature, if there's one process that's used here, it's also used there and here and all over. So it might be that one of the reasons why it's been really formidable to understand all of the many steps of photosynthesis is that you really have to understand the first step, the initial step, in order to understand all the subsequent steps. And some of the researchers in photosynthesis don't really understand that. A colleague of mine brought it up very clearly. If the first step in photosynthesis is the separation of OH minus and H plus, you got to ask the question, why would they want to separate? Because minus and plus want to come back together again. And nobody's really responded to that question.
Charge.
Yeah, but if it's a process that's similar to what I've been describing, the separation occurs because of a physical lattice that builds an easy water, which doesn't allow those positive charges to get back in. Those protons, those positive charges, they latch onto water molecules, and because of that, they're actually bigger than just a proton, and that's called a hydronium ion. This is standard chemistry, and those hydronium ions are simply too big to get back into the lattice. They can't fit through the hexagon, so they're excluded. It's not complicated, and it's possible. I don't say that this is going on. It's possible that the first step of photosynthesis, again, the splitting of water, is actually more similar to what I've been discussing than what the chemists think. I don't. That's a speculation.
I've always heard of oxygen described as a very promiscuous element, that it just wants to go and attach to everything around it. That's why things rust. So it's interesting that quality of these elements want to connect so much and to have different ways of connecting. I think it's interesting when you look at the kind of the geometry of molecules and how they play out.
I do too. Yeah, absolutely. And that's why I would reiterate, it's the geometry that's central. It's these hexagons, hexagonal structure that's really key and critical to the understanding of what's going on. And oxygen has got these negative charges around it, so it will go searching for, in theory,
partners.
Yeah, right, exactly. Sure.
What are the implications for subtle energy? So in life, and I know there's lots of implications we want to talk about how the planet moves, how easy water is everywhere that you say. But what are the implications for subtle energy? Because that is something that we experience a lot in our work, just waves of energy. And I've always wondered, how do you explain that? How do you explain just downloads of just intense, blissful energy? There's just got to be another structure within us where something's activated. So we talked about subtle energies briefly, but what do you have to share about that?
I noticed that uh, uh, um, when you talked about beauty, you looked at your husband, and so I. Okay. Anyways, subtle observations about subtle energy. Yeah. So, yeah. Where to start about subtle energy? Um, uh, Let me start by saying I think this is the frontier of the future, maybe the frontier right now, and it's a frontier that a lot of people don't talk about because it seems so remote and difficult to understand. And you got to realize that, for example, electromagnetic energy only how many 6, 7, 8 generations ago, it was completely mysterious. Nobody had any idea. Nobody could conceive of electromagnetic energy, and now it's a central part of all of physics and chemistry. So the idea that there's so-called subtle energy puts us back in the same situation, of 150, 200 years ago. We don't understand it. We don't understand its nature. And yet, we don't want to dismiss it,
We
or
live it.
some people would like to dismiss it because we don't understand it. And there's some hubris involved in science. Some people will say, some scientists will say, well, it can't exist because if it exists, we would certainly understand it, and because we understand pretty much all of physics and
Yeah,
chemistry, and
that's hubris. Hubris.
it really is. Yeah,
It really is. Yeah,
yeah,
it's like the Wright brothers, right? The scientists of the day. Oh, I'm sorry, but heavier than air, mechanical powered flight not possible. And here they were flying and getting up off the ground, at least on a threshold effect, and they were denying it completely. So
absolutely.
I think it's like that. I think that there's a lot of laws of physics that we experience in our life that have yet to be recognized. That just until we throw open the worldview parameters, yeah,
it's really
missing
true.
so much.
Yeah, it hasn't changed a whole lot. You're referring, I think, to Lord Kelvin, the famous physical chemist who said, as you reiterated, something heavier than air will never fly.
Oh, we've discovered everything there is to know about science, and this was back in the early, yeah.
Yeah, they thought so then, and many scientists think so now. And so the idea that there can be a different kind of energy, which people refer to as subtle energy, for lack of a better term. It's subtle because it's there, but we don't really
Haven't yet
understand
defined
it.
it completely.
Yeah, and so it's our job as scientists. I mean, uh, uh, it's our job to look at what we see in front of us and try to explain it, try to understand it. But many scientists take a different view that it can't be true because we already know everything pretty much that in our modern age that needs to be known.
Right.
That kind of attitude doesn't get us anywhere.
What has the reception been of your work? Because you're talking about here, you have in your cells a whole layer that can conduct energy, right? That is holding energy, and it's flowing through you in pathways that are additional to what we know about the Golgi apparatus in the cell and all the other stuff. So, what has the reception been?
The reception has been split. There are some scientists who have challenged what we have to say. Not many, at least publicly. What they may think, I don't know. But there have been a handful of papers that have been written. One of them by a colleague of mine, you might say friend. I'm not sure if that is exactly the right word, at the University of Washington, with whom we had many discussions, and my view of the discussions, it was a sort of one-way discussion. And when I suggested to this colleague that we should maybe agree to disagree, that was the end of our periodic coffees together. Next thing I knew, he wrote two massive papers very, in my view, complex, difficult to many intricacies of physical chemistry, suggesting that what we've done is wrong. And there have been several other follow-ups, mostly supporting that his point of view. That's one side. The other side, there has been massive interest from so many quarters in this material, not just from people interested in physiology and health, but also people interested in so many other facets of life that somehow involve water. One of them is a guy who builds Olympic ice skating rinks, for example, and has interest in what's the surface of the ice, and we have many communications together about the role of easy water, and he's deeply into that, and the role of light and such, and perfecting these rings. And another one has interest in well, you might say Roman history, and how the Romans used to cool by having water that's flowing, and so all kinds of diverse areas. And and the response to that fourth phase book has been incredibly gratifying. I sometimes, when I'm feeling a little low for some reason, I open up the reviews and start reading some of the reviews of the fourth phase book, and I feel better after 5 minutes, because the reviews have mostly been amazing.
We've talked with Callum Coates in the past about Victor Schauberger and some of the miraculous properties of water, which they noted but couldn't understand. How do fish get the energy to jump up these waterfalls? We talked to Batman Gelich about your body needs a lot more water than you know, can actually be a healing, just water alone can be a healing medicine. So there's so much, we've recognized so much of the miraculous properties of water. So you're putting some science to it. So I can imagine the implications.
Yeah, well,
for health.
Yeah, totally. And that was you mentioned Bhat Mangalaj. I thought he'd passed quite a few years ago, but maybe I.
Well, we interviewed him in the '90s, so it's been a while.
Oh my goodness! Wow.
He's memorable.
Didn't know that you were alive in the '90s.
I was 7 years old.
Late 90s.
Yeah, in diapers. Yeah. And his work. I happened to be on a flight some years ago, and I was reading a book about Saint Georgi, who I mentioned earlier, and it's called something like the Radical, Flaming Radical or something. And the guy sitting next to me was interested that I was reading it and said, I know that book about Saint Georgi and water. I go, really? We started a discussion. This was the son of Bhat Mangalaj, and he was telling me that his father's book sold something like 6 or 7 million copies. And anybody who hasn't read it should read it. There are several different titles, and I think the one that I remember best is "You're Not Sick, You're Thirsty." And the story of this guy is amazing. He was a political prisoner, thrown in one of the most notorious prisons in Tehran, and he was a physician. And there were many people, they're all political prisoners, and of course they got sick. And who did they go to?
All they had was water.
All they had was water. And so he said, drink a lot of water. And the patients miraculously got better just by drinking a lot of water. And when finally the prisoners were released, including him, he or some prisoners, he stayed for 1 year longer because he was doing research on those prisoners who were ill, who were drinking a lot of water. And he continued afterward, and then he wrote that book. And the book is amazing, and it demonstrates the power of hydration of water. And we all get constant reminders of that, about
your body's many cries for water.
Your body's many cries for water. Yeah, very well. So you really ought to be helping to write my next book. I really must recruit you in so many ways.
Be honored. So it's so interesting, the implications for geophysics as well. And I'm wondering, is Jeff on? Does he want to ask his question? Should we wait for Jeff?
I can't see you at this moment.
But you said there's a lot of mysteries just going around observing life on the planet that can be explained with easy water or this fourth phase. Do you want to list a few of your favorites? For example, how does water get up a 100-foot tree in those little capillaries?
Well, yeah, that's one. How does it? Yeah, or a 300-foot tree, 100-meter tree. Some of the redwoods in California. This is the question, because if you think about it, if you were to take a tube mounted vertically, fill it with water, let's say a 10-foot tube, which way does the water want to go? Well, it doesn't want to go up, it wants to go down, right? All that pressure from this. And now imagine a similar tube that's 300 feet tall. The water absolutely wants to go this way, not that way. But it needs to go that way because it needs to get up to the leaves. So how does it do that? And we found what I think is the reason. We found, again, this is another undergraduate student working in the lab who was taking these tubes, and the tubes were made of some hydrophilic material. The tubes were made of a material called naphthalene, which is a little like Teflon, but it's charged. And his task was to go to the laboratory and see if next to the naphthalene surface, next to the curved surface, you also got the buildup of exclusion zones, fourth phase water. He quickly found that, yes, that was the case. And he went on, because of his curiosity, to go further. And only a week or two later, he comes rushing into my office. And I remember, because I had a visitor sitting next to me. I think it was an important, quote unquote, visitor, but it wasn't so interesting. We were talking, and he comes barging in. Usually the students don't barge in. They tend to be more polite, but he came barging in. He said, I found something different, unexpected, and I thought that you would be interested. So he starts telling me. I'm curious, what could be so interesting that he would interrupt a rather formal discussion with somebody. He said, I noticed that I put the tube in the water, and the water was flowing through the tube, and it wouldn't stop. And I thought, oh, this is pretty interesting, because usually if you've got a tube and you have flow through the tube, you need a pressure to push the flow, because the water has viscosity, resistance, and you need energy to drive it through. But there was no pressure gradient here, because the tube was sitting horizontally, and the pressure at this end and this end were the same. The water was pressing down equally on both, yet the water kept flowing through. So I thought, oh my God, if this is right, if the student is right, this is evidence for what we had just discovered, that the infrared energy is coming from the environment, absorbed by the water, and this was the energy that's required to build the EZ and do other things that are related to the EZ. So we found that this flow was real, and also if you took the tube and oriented vertically, the flow would continue. So I think this is the principle, same principle that's used inside of plants and trees for the water and it doesn't come
It's very
free.
obvious that glass tube is going to have different qualities than living tissue, right? Right there, that would make good sense.
Yeah.
And your lab sounds like a very fun place to work and to hang
Well,
out.
thank you. It is, but there's a but associated with it, and the but is that our laboratory, there's been a lot of space pressure, and I must tell you that our work is not popular in my own department. and
I am
and
shocked. I am
yeah,
shocked.
yeah,
Look at the
you understand.
implications. Look at the potential. Look at the possibilities. Look at the technologies that could come from this. Look at the answers. It's joyful. It's brilliant.
The
Well,
politics of academia.
you're very kind, very
You're,
kind.
you're uncovering a secret to the universe. That,
Well, thank
that
you.
it really means that life out there, that the universe itself is set up so that life thrives, that life's possible, that we're not a fluke, we're not alone. It's got to be out there. We see the signature of water out in space everywhere. Tony, you can tell us about that. It's like it's so exciting. We should take questions.
Yeah.
Let's open it up to questions and comments. But
As you like,
Yeah.
whatever. Yeah,
you
but
can say that you're not popular in your own department. Is that because you're threatening our standard worldview? What do you account that for?
Politics of academia.
I can't imagine a more pleasant and generous person. So it's not like your former mentor. So.
yeah, well, I think you understand that very well. That when you challenge the status quo, that's not a popular position, and it impacts the thought processes of people around you who teach the students what they think is truth, and here is this fellow faculty member challenging pretty much everything they're teaching the students, and I understand historically that those people who challenge the status quo, they often suffer. They don't get burned at the stake, but
But the Inquisition is alive and well.
it is
Still.
alive and well. That's right. And so I have tenure, and so in theory I can't be fired for my position. But there's also a space issue, and when space is needed for somebody else, there's a kind of vulnerability, and I've had to wage various battles against the administration, and so space has contracted somewhat, and I'm always feeling under pressure. And when the space is contracting, and the people are widely spread on different floors and such, it's less cohesive than it could be or once was with everybody, all the many students and postdocs congregated in the same space.
I bet you're a popular place to work, though. I bet there's.
It has been very popular. It has been. Yeah. I got to say, I'm proud of it. That we at one point a few years ago we had something like 30 undergraduate students. Most of the students are either graduate students or postdocs or even older. But students would come from different departments attracted to the kind of thing. And I was told by the administration of the university that was a record. That no other laboratory had so many undergraduate students working there. And I also must admit it took so much of my time because I was dealing with every one of those students personally. It drove me nuts. And, my late wife used to tell me, she said, Jerry, you're running 5 careers simultaneously. It's too much. And she was right. Okay, anyway, I'm just blabbering on.
No, you're not. No, you're not.
What are you even saying that there's implications for gravity? What are you challenging? What's the far reaches of the paradigms that you're challenging?
Well, yeah. So gravitation is coming in a forthcoming book on dealing with the subject. And most of us think that gravitation is clear and understood and well known, but people don't realize that the theory about gravitation doesn't always work. It works in some cases, it doesn't work in other cases, and one of the best examples is the so-called dark matter. So you've got galaxies way out there that are revolving about one another, and if you consider the mass of you ought to be able to explain the rotation based on the masses of the two, it doesn't work.
There's something missing in the
There's
equation.
something missing, and it's not 1 or 2% that's missing. It's 90% that's missing. And so the result, is since gravitation based on mass has become a mainstay of our understanding of the universe. The idea is that that paradigm must be correct, and therefore there's got to be a kind of matter or mass that we can't detect. It's there. You might call it subtle, as in subtle energy. It's there, but we can't detect it, and that's why it's called dark matter, because other matter radiates, but this doesn't radiate. You can't detect it, but it must be there. And so it's a kind of, if you look at it from afar instead of from inside the field, you think of it as a kind of Band-Aid that covers a gaping hole in our understanding of gravitation. You've got to add this extra thing to make it work. And some of us don't like to add little extras or extra plugins to make things work. It should be simple.
Theory should be elegant. It should hang on its own. Yeah.
I agree with you 100%. It should be elegant. And this is not elegant to add. And so there are other...
It means there's something missing in our original equation, in our basic premises.
Exactly. Mm-hmm. It's not just that. There are more issues, and you could make a list of half dozen issues, areas where the theory doesn't fit. But most of us don't know about that, don't think about it, and we're quite happy with our understanding of gravitation. And I don't want to go into great detail, but let me just say that I think that somehow electrical charges are involved in the attraction of gravitation.
And I think the universe is mostly plasma, many people say, and that is all about an electrical charge going through that we're not recognizing. And
agree. The charges are all around us, and
it's an electrical.
It's inescapable. But for the most part, we don't take them into account. Even the charge of the Earth itself is so central to so many phenomena, and I think, including gravitation that you mentioned. And that's what my forthcoming book is about. As soon as my son can extricate himself, my son, the artist, from doing his home remodel, so he has time to finish the illustration, so the book can go out. But it deals with the role of electrical charge in nature, and it's profound. It's all over the place. I argue that it ranges from what turns the Earth, what makes weather, gravitation we mentioned, how birds fly, how some sailboats can actually sail directly into the wind, why planes can fly upside down. So many phenomena that we think we understand, but if you penetrate one level beyond the superficial, questions begin to raise that you can't answer in the current paradigm. And I think you can answer them if you take into account the electrical charges that exist all around us, especially inside the Earth.
And wouldn't it be interesting if our eyes could see the flow of energy on that level, which we don't, but insects see infrared. If we had that capacity, we'd probably see a lot more. Paul, do you want to?
Well, I was going to say that if you would like to ask questions, why don't we use the raise hand function of Zoom? Just go down to the reactions button, click on raise hand. I know that there's several questions that have already been asked in the chat room, but rather than having me scroll through and read questions, go ahead and ask your question. And then let's start off with next week's guest, Jeff Volk. Unfortunately, he had a competing conflicting event. Yeah, not competing or conflicting event today. So he sent it to us via email ahead of time, and I'm going to give it to you. Here, you read it.
He asks, let's see, what about the tidal drag of the Earth's saline waters that might create a battery effect as it flows against the magnetically charged subsurface of the ocean floors due to the iron-nickel core? What kind of EM charge might that generate? And how would that change the structure of the water, which would be under a great deal of pressure at that depth? and could have a whole lot of consequences on the kind of life forms that might develop thereabouts.
That's a good question.
Okay, yeah, good question, but there, various premises that I'm a little bit reluctant to be sure of. The first one is, where does the Earth's magnetic field come from? And the usual explanation is indeed the iron core and the various flows inside the Earth, but nobody's been there to check to see what's going on. It's not so easy to do that. You can muse as a child about digging a hole and lining it up in China, but it's not so simple to get there. And there's another possibility about the magnetic field, and that is the solar wind, which brings positive charges which flow around the Earth. And there's another possibility to explain the magnetic field of the Earth. And so I think that's an opposing hypothesis, but let me just bring up one additional fact, that a finding that we've just come upon in the past year or so, not yet published, and that is that has to do with water and magnetic fields. So you might not expect it, and we weren't sure we would expect it, but what we found is that easy water builds next to the South Pole and also next to the North Pole. So the experiment it couldn't be simpler. You take some water and take some particles that you put in the water. We use those particles to detect the presence of easy water, fourth phase water, because that water excludes the particles. So wherever we see that particles are excluded,
that could be the mechanism.
That's easy water. So you put the magnet inside the water and expose the South Pole on one side, North Pole on the other side, and voila, what happens is the microspheres get excluded just the same way as we've seen from so many different substances. They get excluded. And
isn't that where the solar winds are coming in? And
well, yeah, the solar winds could be not exactly in our experiment, but yes, the solar winds I think could be related. But what I just wanted to say is that we can see that the magnetic field, or the magnet in some ways, and it's not the material of the magnet because we covered the magnet with like saran wrap or something. So the material of which the magnet is built is not the cause of this. It's the field of the magnet. And it builds an exclusion zone, and dynamics of that exclusion zone very closely resemble the dynamics of what we've seen with other materials. So if our result is correct, I think it's correct, then that phenomenon needs to be taken into account, right? And so it means that the magnetic field that exists of the Earth, whether it comes from the flows and the core of the Earth, or whether it occurs from the effect of the solar wind.
Or just spinning. A spinning planet is going to...
Spinning, yeah, there could be lots of...
create an effect.
So we need to understand magnets and how magnets work. And if you look at the literature on magnets, you quickly come to the conclusion that nobody really understands how magnets work. It's incredible, in this day and age. But so of course I've come to my own sort of understanding about how magnets might work, and I think that a possibility is that both North and South poles have charges on them, one being positive, one being negative. I don't, I want to go into the evidence in great detail, but
we have lots of questions. So.
Yeah, you have lots of questions, and maybe it's too much detail. But I got to tell you just one thing.
Sure. Yeah.
And that is, it's a slide that I often show, and up until recently, I thought this is so mysterious. It's shown demonstrated by a Japanese scientist, and I saw it 10 years ago, and I have a slide from him. And he has a container of water, a trough of water, And he puts a red dye in the water just for effect. It could be obvious why why he puts a red dye in a moment. And behind this trough of red dyed water is a magnet. It's a superconducting magnet, it's very powerful. He turns on the magnet, and what happens is that the Red Sea splits. It actually splits, and the water moves to one side, the other side, leaving a gap through which Moses could walk in this Red Sea.
Wow.
For me, it's a phenomenal observation, but it demands explanation. And I do think if a powerful magnet is creating exclusion zones, the exclusion zones are charged, and one might be negative, the other positive, and they're going to be moving toward the magnet. So it wouldn't be a surprise if they move toward both ends of the chamber. Not sure that it's a speculation, but it could be. So anyway, let's go to the next question. I don't want to.
Well, you brought something else up, that light is a nutrient, just like water is a nutrient. We've heard this a lot, that light is a nutrient. How do you respond to that claim?
I think it's brilliant. I never thought of it in terms of being a nutrient, but that way you can explain how some people can get by without eating.
Right.
We all need nutrients. We think we need food, but as you, I'm sure, well know, there are lots of people around the world, some of whom I know, who either go through periods without eating or for very long times without eating. Long times meaning from days to weeks to months. And the extreme is this guy from India who has been deeply studied by scientists and physicians.
We watched a documentary on that. Yeah.
Oh, yeah. Okay. So you know about it. For more than 65 years without eating. In his case, without drinking too. But it's a humid environment. And when the environment is humid, you can breathe in water. But the light is a nutrient too, because where does the energy come from? If you're not eating, you don't get that food. But what's sustaining you? I even know a dancer who telephoned me once and said, she dances. It's an extreme physical activity. But sometimes she decides, or she feels like not eating, and she can go for a month without eating, but she's dancing. And imagine the energy that it takes. And then she decides she's going to go back to eating. So the nutrients, she needs nutrients of some sort. Energy is required. This is a fundamental law of nature. And where does it come from? So the concept of treating light as a nutrient, we absorb light all the time. It's a perfect way of describing it. Thank you for this rich question.
Let's take a couple of questions. First of all, Tony Hall, who is an adjunct professor at the University of New Mexico, an astrophysicist. He has been asking several questions in the chat room, but let's just put them on.
Hi, Tony.
Hi, Jerry, and thanks so much, Paul and Laura. Splendid presentation. I'm just full of questions, and I don't expect to take up all the time by asking them all. But first of all, you kind of scared me. What happens if you have an MRI where we're put in a very powerful magnetic field?
Well, there's first of all, there's the experiments of the guy. Sorry, I'm blanking. Graphene guy. Want to know about? Sorry, what?
Yeah, go ahead, please.
Yeah. And he was doing experiments early on, putting frogs in the magnetic field, and the frogs would lift in the magnetic field. He thought it was due to the water in the magnetic field. So the variability to use MRI for imaging rests exactly on the fact that the water is not ordinary liquid water. It's structured in certain ways. And it all began in the laboratory of Gilbert Ling, when Ray Damadian, a physician, thought that pathological tissues, that the water may be different than pathological tissues, and he and Ling worked together. And he had the idea that you could use this for imaging. And he went ahead and built an imaging device, the first MRI, based on the principle that the water inside our body is not all, it's not liquid water, it's structured in various ways. And the structuring in each piece of tissue differed in subtle ways from the structuring in other places. And you know, he was the father of MRI. And unfortunately, when Nobel Prize was given, it was given to several people who developed and perfected the technology, but not to Dumadian, who was the discoverer of this technology. And he came forth with a full-page ad in, I believe, the New York Times or Washington Post, saying the Nobel Committee made a big mistake because he was the discoverer of all of that. And, you know, I think he has a legitimate position, but he would be more of a sort of controversial guy because he worked together with Gilbert Ling, who was extremely controversial. So the Nobel Committee bypassed him. And yeah, so answering your question, the structuring of water is absolutely central to our ability. And if the water were not structured, if our body were filled with liquid water all at the same time, we get no image.
One of the things that kept on coming up is that this seems to have very fundamental implications to life. And I would think there would be interest in looking at ways to commercialize this. And my greatest fear is that Monsanto will patent water.
Wouldn't put it past them.
Yeah, there's history to suggest that might be the case. Yeah, I mean, water is so central to everything in life and beyond life, and I know that companies are buying up water supplies. You know, and this is going to be is already a really serious issue, and also obviously the water pollution that, you know, the water that we drink is full of pharmaceuticals of all sorts. And so I'm not sure when you speak of commercialization, yeah, it is possible that some large company is going to buy up all the water supply and have a monopoly on it, and we need it for survival. So,
well, I meant specifically what the fourth state. If there's some way that the fourth state could be exploited. Yes, of course.
Your research, yeah.
The technologies.
Oh yes, it can.
What do you do with fourth phasing?
Yeah,
they're and this sort of gets back to the question of subtle energies, because see, I think my hypothesis is that it's the easy water that has the capacity, because it's like a crystal. It has the capacity to absorb information from the environment, and I think that it's our fourth phase water that is actually the receptor for this subtle energy, and we're studying that right now with healers, for example, healing right in the presence of beakers of water. We're looking at this water before and after these healing sessions to see if we could pick up any differences. We have no definitive results yet. The experiments are going on, but we're optimistic that we're going to find something.
Interesting.
And it sort of makes sense because this stuff is like, in some ways, like the computer memory. So if you, the easy water, if you think of how computer memory operates, it's a three-dimensional array of transistors, silicon-based transistors, and each transistor could have two different states, which is referred to as 0, 1, on, off, or whatever. And the easy water is very similar to that, but even more powerful. It's got that three-dimensional order, those layers that I was talking about. And it turns out that the oxygens, this is standard chemistry, textbook chemistry, oxygen has 5 different oxygenation states, oxidative states, I should say. Not just 2, 5, and -2, -1, 0, +1, +2. So in theory, the capacity for information storage if you do the arithmetic, it's something like 7 or 8 orders of magnitude higher than the today's standard silicon memory. And so, and this exists inside of our body. And if you, Tony, are sending some subtle information to me, as I can sort of feel right now, it may get absorbed in the easy water that's inside of our body or brain or whatever. And that's how, this is a hypothesis now, that's how the subtle energy is being received. So
Or transmitted.
Transmitted, received. So this is really important and could be exploited in many different ways, positive ways, but also negative ways. And so if what I said, it turns out to be valid, I could imagine how some destructively oriented source might wish to exploit that, and perhaps it's already being exploited to give us negative energies instead of positive. The person who's been studying this sort of thing in great detail, there are many actually, but Luc Montagnier is he won a Nobel Prize for discovering HIV, and he's deeply involved with the transmission of this kind of energy in the human body. It started earlier with his demonstration that DNA, the information from DNA, can be transmitted from one water source to another water source simply by putting the two close together. So you have one container that's filled with DNA and water, and right next to it, another container with just water.
Okay, that's homeopathy.
Yes and no. It is related to homeopathy because the DNA sample has been diluted many times. So it's mostly water, maybe a little DNA, maybe no DNA, and the water. And then you throw this one away and you take this water, which he claims to be informed from the DNA or the water that surrounded the DNA, and you use the PCR method to make new DNA, and the structure of the new DNA is the same as the structure of the DNA that had been sitting next to it. Amazing. And then when you think about the implications for subtle energies that could be transmitted negatively, positively, there's lots of potential there, both in the positive sense and curing diseases, and also in the negative sense. So I think you're right on about that, Tony, and this could be used, and especially now that it's possible to take the easy water and take it and make a solid powder, at room temperature. So it was achieved in Italy by Vittorio Elia, a very competent biochemist, and he's had several papers reporting that. And we've taken it upon ourselves to duplicate his experiment, and we absolutely confirmed what we found. And I think we've gone a little bit beyond to make sure that there are no contaminants or anything to influence the result. And we're now putting that together for publication. So if you take this amazing solid water of some type at room temperature, if you think about it, it boggles the mind. Solid water at room temperature, but it's basically crystalline water. And if you got that water, it could be easy to take that and impart some kind of energy to it, and it should change the structure of that solid. So yeah, long answer to your short question. I hope.
Well, look at the implications for the computer chip industry, right? Aren't they trying to use water to make computers now on the leading edge?
I think it will in the future, once the computer industry gets wind of this. Yeah.
4 years ago, there was a scientific American cover story on new origins of life, which began with the transport of water to Earth on comets. and then the process of millions of experiments that would happen in hot springs and things like that, that began to produce the RNA and DNA of life. I would have to think that this water you're talking about would have something to do with that.
Well, yeah, I mean, yeah, it's easy to speculate on the origin of life, and but you know, none of us were there, so. but I just in response to your question, there is one feature that I think it's hard to argue seriously against, and that is uh, if you have whatever materials existed on the face of the earth at the beginning, in order for life to exist, they have to kind of come together, and there's got to be a way for that to happen, and the easy water actually does that. It brings molecules together, and it's based on sun's energy. So I think this could easily be a first step in the origin of life, taking whatever molecules existed, who knows what they were.
I actually think it is, and I know the people who wrote the article. I'm going to ask them if they would look into this.
Oh, sure, that would be.
And one last question, if I could. What is the implication on the water we drink? I drink water from a 400-foot well beneath my house. But there's distilled water, there's smart water, there are all sorts of things out there. Is there any implication on how we choose our water to drink?
Yeah. So again, this is a can of worms that you open, and the answer is not so simple. But the short answer is yes. It does matter, and what we've come to think based on our research is that if you drink water that contains reasonable amount of easy water in it, it's going to be good for health, because every cell in your body has easy water, and a cell that's deficient of easy water is not functioning properly, because the process that the cell needs to go to do whatever its work, the water is central. And so, for example, if you have a muscle and the muscle is somehow deficient, not filled with easy water, but deficient in easy water, it may contract, but it's difficult to get it back to a relaxed state, because you need easy water to do that. And if somehow your cell is not doing it, it's not functioning properly, and you may get a cramped muscle or something like this.
Okay, so how do we get easy water?
Well, I'm getting to that. Well, first of all, there are companies that tout that their product contains either fourth phase water or easy water or structured water or whatever, and they may, but I'm not sure, because they don't usually publish the evidence for the presence of easy water. But there's a way to sort of get it, and one way is to use your 400-foot well, because we found experimentally that if you exert pressure on water in a 400-foot well, you'd expect that the pressure of 400 feet of water would do that. Pressure converts ordinary water to easy water. We found that experimentally. We were investigating hyperbaric oxygen therapy, where you have high pressure and high oxygen. And we found that both high oxygen and high pressure build easy water. Why should pressure do so? Well, I think it's because the easy water structure is more compact than ordinary water. So if you take ordinary water and you press on it, the equilibrium is going to shift toward easy water. And we did confirm that experimentally. So there's a good likelihood that your water, like other spring waters, should contain a fraction of EZ. And we can test it. I should say it's possible to test it. Anybody can test it. We don't do testing of water, commercial waters. We don't have time to do that.
I see that Stephanie is saying we can taste it, and I'd love to have you comment on that.
I have no comment on that because I think, but I'm not sure. I think it tastes smoother than other waters.
Had that experience.
I'm sorry.
I've had that experience. Smoother, wetter. Yeah.
Smoother, wetter. Yeah, it's water wet, right?
There's also implications for filtration, right? If you run your water through an easy water processor, whatever that technology of the future might be, you would push out the impurities. So it has filtration.
Yeah, exactly what our company, our startup, had been trying to do for a while. We ran into some technical difficulties, which meant that we had to do some more research to overcome. But in theory, yes, because EZ water, fourth phase water, it's easy because it excludes. So if you have let's say a system, you input water into the system, and the water is filled with any kind of junk that we encounter on a daily basis. And that water that's coming in, there's a process that creates easy water from the water that's coming in. The easy water will have pushed out all the impurities. And the water, if you collect the easy water, which we've been trying to do, should be water that's not only free of the impurities, but also structured, containing EZ, you see. And so that water should be ideal for drinking.
It also seems to me that lifestyle could also rev up your cells with more of this easy water or the conditions for your cells to make it. For example, grounding or earthing, right? Just walking barefoot on the earth, you have the negative ions, and there's various things that I think lifestyle would help you.
Absolutely, yeah. So indeed, walking barefoot on the grass, wet grass, or walking near the seashore, you're connecting yourself electrically. And true, the negative ions from the earth will run through your body. Any place that's deficient in EZ, in theory, EZ should build, because we have found that if you stick a negative electrode in water, EZ water builds around that negative electrode. And so if you connect yourself to the negative earth, same thing should happen. That's theory. I don't know, whether it's correct, but it makes sense to me that would be one reason why connecting yourself in any number of ways. You can hug the tree, you can walk barefoot, you can connect yourself artificially, so to speak, by driving an iron rod into the earth and connecting with a copper wire to a plate on which you put your bare feet.
We got
all of those.
Group and experimented with that.
Yes.
Yeah. That was
you have, yeah.
Thank you, Tony. I'm going to go to Brian
Good
next.
questions.
Okay,
Yeah.
Brian.
Jerry, this was a wonderful talk. It's
Thank you, Brian.
There's a quality of listening to you speak. We can feel your enthusiasm and your delight in what this topic has meant to you for all these many years. So my question is maybe to learn a little bit more about your personal journey, whatever you would share with us. But do you find yourself, being changed by your notions of what it means to live in such an exquisitely designed universe, where properties, the emergence seems to come out of complexity? From simpler forms, we seem to live in a universe that creates complexity in that sense. What's come alive for you over the years as you observe the universe from the perspective of water? How has that shaped your consciousness and your journey?
That's a really good question, and I must admit, I do a lot of interviews, and that question has never come up, but it's a good one. Well, I guess how it's shaped my consciousness is an appreciation, actually, rather than for the complexity of nature, for the simplicity of nature. And I don't know how you would use the word complexity, but what I'm referring to are the essential principles of nature. And I think Mother Nature operates along the lines of the principle of simplicity. The underlying fundamental mechanisms, I have come to think, and I guess after doing science for many years, I'm entitled to a philosophy, and that's my philosophy, is that the fundamental principles of nature are extremely simple, and the simple principles may, of course, lead to what looks like complexity that we observe. But if you go down and dig down deeply, those underlying principles are simple. And that's where I've come to be. I think I've maybe always thought about simplicity, but now it has really crystallized, if you will, that nature works in a simple way. And I may go to an extreme that you might or might not agree with. When I open a book and start reading a book that's scientifically oriented, if the principle that's underlying principle is a simple one, my first reaction is this has the ring of truth to it. It may be, and if the underlying principle is complicated, I shake my head and say, I think first thought is there's something wrong with the fundamental principle. It can't be that complicated, because if you build on a complicated foundation, everything becomes so extremely complicated that it becomes even hopeless. And when you try to understand, when you scratch beneath the surface, it looks even more complicated. And this is not an original principle by any means. You probably are familiar with so-called Occam's razor, Sir William of Ockham, who originally devised the principle of simplicity. And he was a theologian, and he was referring to the question of, does God exist or does God not exist? And he said, well, you can argue both ways. And in all likelihood, the simplest explanation is likely to be the one that's correct. So, and then it was Newton, a few hundred years later, who took up that principle and said, hey, you guys, same principle ought to apply in nature, that mechanisms should be simple. And that precept has prevailed over many years, the principle of simplicity. And it got interrupted in the beginning of the 20th century when the physicists began an understanding of quantum mechanics, which is not simple, which is, you might say, should I put it, it's abstract mathematics. And, you have to ask the question, does nature require abstract mathematics to understand her principles? I'm not so sure, but this concept of complexity replacing simplicity has persisted over the years. And I know some of my colleagues will stand up in front of the audience at the podium and start showing slides and try to demonstrate how complex is what they're studying, as though, hey, look how smart I am because I can understand all these complicated things. And my own reaction is, well, I'm not so sure about that, because
nature's elegant.
Nature is elegant. I think that's a better way of putting it. Elegant. I use the word simplicity, but
actually,
it's universal.
And Nez happy throughout the term in the chat room, simplexity.
Simplicity. Yeah, that's a good word. So anyway, for me, that's what's come of it. If there's any one sort of principle that I've come to over the years, it's that, which has unfortunate sequelae, because I'm deeply interested in not only the nature of what goes on around us, but also what goes on inside our bodies. And I've been studying or thinking about how our body and how our cells work for many years. And so I have that book in mind. It's a book on physiology of the human body. And I would like to write that book, but I got two other books that are sort of
in the works.
And and so many other things going on that it takes time. So I need to maintain, persist in good health. And my naturopathic doctor says she's going to keep me going really strong for at least 40 more years. So
That'd be good.
I
I want the name of the doctor.
I see you're sitting next to a acupuncturist, and so I would love to hear what Joseph has to say real quick on meridians.
Oh,
So,
he's coming to the microphone. We can't hear you from there, Joseph. Unfortunately.
so
Yeah, Laura, she always calls people in.
I'm an
That'll teach you to
inclusionist.
sit in the background.
Bye, Laura. It's been a fascinating talk. Thank you, Jerry.
Oh, thank you. Thank you. Yeah.
I'm sitting here kind of drawing and doodling as you're talking, kind of coming out with imagery to kind of just spurred on by what you're talking about, water and energy flow. It's been fascinating. And everything is about energy. And I've been studying Qigong and about how just it's all about the Qi, the flow energy within, and just activating that. And water is a big part of it. I mean, in Chinese medicine, they say where the mind goes, the mind goes, the Qi follows, and it's essence, water, liquid, but also our thoughts.
Where the mind goes, the chi, the life force follows.
Thank you.
Yeah.
Yeah.
Yeah, we need to learn more about this, and I think it's going to require scientists to open their minds and begin studying to attempt to understand better how these energies flow.
How they work.
The meridians they could be possibly channels that have structure of some sort, and the information flows along these. That's a possibility that I think should not be ruled out. It's the frontier, absolutely.
Yeah.
Yeah. Thank you.
So you are working with healers. So healers can do effect at a distance, Einstein's spooky effect at a distance, we could call it, because we've seen him at work. We've had a panel on energy healers talking about that. Our own work, Jerry, we see effect at a distance. We see huge downloads of information, of energy, emotional content, oneness with the universe. How would we participate in an experiment to see if what we do also amps up greater easy water in our cells that could be measured, to explain conduits, waves of energy? We could have some of our participants talk about and describe their experiences with downloads of information, downloads of insight, energy. It just seems like you're sticking your finger in the circuit of the universe's life force. I'm sure Jedi training would have involved this or something like it. So we can have a lot of mythology, a lot of conversation around it, but there's something that's happening.
Yeah, I hear you. So my first hypothesis is that this information is stored in our water, and the way it's stored in our water is it's stored in the easy water. So I mentioned to you that the easy water contains the oxygens and hydrogens. The oxygens have 5 different states, and it's easy to envision that any one of these oxygen atoms sitting there could receive this energy and transform from, say, one state to another state, from -2 to -1 or something, or -1 to 0. And that's information. And it changes in a subtle way the nature of the easy water. See, the easy water, the honeycomb structure that I described to you, is a kind of template. Well, not template, that's the wrong word to use. It's it's a
Lattice?
Yeah, it's a lattice, but it's a generic lattice, and the generic lattice, it can then be altered in many, many ways, in practically an infinite number of ways, to store the information. And so, the first hypothesis that I would come to is again, it's hypothesis, it's even speculation. The energy is coming in. We don't understand the energy. It can be transmitted over huge distances, unlike standard electromagnetic energy, and received in our body. And the way it's received could be that the oxygen or some of the oxygen atoms and some of the lattices and some of the cells are altered in a subtle way, but that subtle way is enough to change, to essentially change the cell, or to change the behavior of the cell. So this is my sort of concept about how this may be going on, and it's not trivial to test this. I've got to tell you, I'm not sure exactly how to test it, but we're thinking about it, and yeah. So that's my response to your question.
That's sort of like with the question.
There's no device you can stick on your skin, and pick up.
Well,
there might be in the future.
Yeah, and that was Sharon's question, which is kind of applies to your question. Could the easy theory be applied to the concept of collective consciousness?
Yeah.
So, yeah.
Well,
it's broad.
Yeah, it's broad, and it brings to mind the idea that the collective consciousness and there could be something in the air I'm talking about, and that is we think that humidity, and there was always some water in the air. We think of humidity as vaporized molecules, but it's not only that. Some of the water that's evaporates. We've seen this in the lab, and we published it as tiny little droplets that emerge from the water. And each droplet that's there, there are droplets because when it's humid, you can't see very far, and because the light is scattered, and it's scattered. Individual molecules essentially don't scatter light, but if you have something that's the size of a droplet, even 10, 20, 30 micrometers, it scatters light. I mean, you have enough of this stuff, it scatters enough light that it's difficult to see at a distance. And so when it's humid, hot and humid outside, your vision is impaired. You can't see a building at some distance will be fuzzy, and it's because of that. So there's little droplets in the air when it's humid, and even when it's not humid, there's still some. And each droplet contains easy water, as a like an onion layers, and this is the same easy water that we've been talking about inside the cells. It can store information, and the reason I bring this up is when you talk about collective consciousness and you try to think about how the information is there and can be transmitted. It's possible that somehow the environment, that the water in these droplets in the air, including the cloud, can contain the information. And as I mentioned about Luc Montanier's observation, that it's possible the information goes from one to the next, and it gets transmitted this way. And so it's possible that there could actually be a substrate for the information that would be involved in this collective consciousness. Obviously, this is a speculation.
But I think of it like, here's an analogy, that you have an ocean and whales have found that at a certain depth with certain temperature, certain this and that, they just know where to go. They can send their voice across half an ocean to be picked up by the next whale, right? They can communicate beyond how we normally experience sound waves to propagate through a medium, because they've found that particular layer, their frequency, whatever. I think of it that way too, that somehow there are certain wavelengths or frequencies or layers or some opening in the substrate where we can communicate across distances. We have shared experiences in a community undergoing our various ritualistic technique to go into a hybrid state of a waking dream, right? Where this has been tested in the lab. Theta plus beta, those are two different frequencies. It's normal, not common. And somehow we are sharing information at a distance. We're scattered across the globe in our international community over Zoom. So we're seeing these interesting effects. We're seeing that we can open up a body of information via an ancient artifact activated in this way, and we get a download of information quite often, transmitted from an ancient society into the here and now that we're picking up. So it just feels to us that either the universe has ways of communicating with us in the here and now in these subtle ways through these experiences, and that we are activating some kind of, we call it frequency for lack of a better word, some kind of medium, some kind of opening, some kind of portal of exchange. This is a mythopoetic language, which is, I'm an English major, not a scientist. This is the language that best suits the experiences that we have. And I know that we're not alone. I know that there's so many other consciousness raising modalities, practices in which this phenomenon, because I've talked to those people, happen. So what is happening here? And so this is from science, but we're living it.
I wish I had answers to your questions. I don't. I can only. What we try to do is to take what you might call conventional understanding and try to interpret, moderately conventional, I should say. Try to interpret the phenomena that you're talking about in those terms. It may be hopeless because it may be that it's impossible to do that. It may be that that our fundamental understanding needs to progress to a higher level in order to understand the issues, collective consciousness and such, and healing and group healing and prayer and such. Otherwise, so our tools are limited, and what we attempt to do is to try to use the tools that we do have to understand these features, but the tools may be inadequate. It may be that it will take many generations before some formal understanding actually does arise. Don't know. But it's a great question.
Yeah.
But what you've given us today is truly an understanding of how simple nature is in this design of a universe, of a planet, of this little biosphere layer that we have on this rock traveling through space, and how it seems to be replete with life's dynamics to support it, to create it, that there's no accident here. We're here because the universe ordained it through its very organization, through its own structure, through the combination of laws of physics. That's so exciting. It's so supportive. It's so miraculous. It's just awe-inspiring to just contemplate how it all works. I know that we've peeked one little more secret of 1% of knowledge of how it all works, but each aha experience is such a delight to behold of how it supports and creates and breathes life into being, this universe. You're talking about the molecular structures and how it does what it does, how the sun shines on the earth, and how it drives all of this to happen. I'm at a loss of words. It's just so beautiful. It's beautiful to contemplate.
Oh, your comments are wonderful and so kind and so thoughtful, and my only great desire, I have no response to that except that I wish I could recruit you to help write my next book.
Well,
you're too kind, but it's the alchemy. It's the wondrous alchemy of nature.
And also
to
to come
take
back,
this together, but it makes more than the sum of its parts, and it's happening on multiple layers, and
and to come back to Brian's question, and that is that that what compels a person to spend their life in a field of research where the joy of science, where does that exist? Where it's not just the ego or the protecting one's territory or the kiss-ass
You're such a
academia.
generous scientist, giving credit to all your students and those who came before.
Yes, and also making your knowledge available to the layperson, because I'm not going to help you with your credentials in any way. All I'm here is just someone who wants to understand. So for me, that's the joy of it. And I know in preparing for today's presentation, I did a lot of Google searches and other kinds of searches to understand your research and to kind of put it in perspective.
Watched your YouTubes.
And YouTube videos and things like that. And it just, such a deep appreciation for what you bring to the table. I know that there's comments on the web that you should be getting a Nobel Prize for this work. I mean, there's people that really get it. They see this is something significant.
We'll send you the chat.
Yeah, that's being brought forward, and I understand, like I said, about how academia has a tremendous amount of politics in it, and that you haven't become discouraged, and that you move forward with your work in the way that you do. And we're so incredibly pleased and excited to have you here today and what you shared with us. And hopefully, if we can be of any support whatsoever, we're there for you. But
Oh, thank you. You're both so kind. I appreciate it. It's been a great pleasure. I must admit. So.
And I know Brian's comment was about the deep time, the deep history of the universe. Brian Swim's work and Mary Evelyn Tucker and Thomas Berry. He was coming from that angle about how life can unfold its complexity because it's all come together to support the evolution of life. And that it's built into the DNA of the universe, that life would exist and thrive and grow and evolve, that the universe is an evolving entity in and of itself. So that this aspect of understanding water and this hidden property of it just goes all the more towards that. So
we look forward to more. Right? We know that your research is
look forward to the technologies
and your new
that come to
publications.
bear.
It has been asked several times. Are you what's the status of your new publications and your work and all of that? And so we want to stay in touch and hear about this as well as it comes forward.
I'm thrilled and delighted.
Gary Hawkins, we have to acknowledge Gary. Gary was the one that handed me the book when it first came out. He said, I read this, now you must.
He's sitting in Lake Washington on his boat, looks like. Gary's our mad scientist friend. And,
builds Tesla coils.
Yeah.
First time we met Gary, he took us to see his 20-foot Tesla coil in some warehouse in Seattle.
Yeah, something like that.
Oh, is that right? How interesting. Yeah.
Hi, Gary.
Hey, Gary.
Hi, Paul and Laura. Dr. Pollack, I guess it was 10 years ago now. Time flies. You were so gracious, and I guess I just kind of marched into your office and you invited me to lunch, and then gave me the copy of your book and signed it, the copy that Laura has now. And Laura, I'd like to have that book back so I can.
Yeah.
Should have put him on the.
Is that a sailboat that you're on right now?
Yeah.
So I guess we could end with
Thank you, Gary.
your sailboat can go up to maybe 40 degrees or so off the apparent wind or something like that. Right? Something. But there are certain boats, ice boats. You know about ice boats? They're like your sailboat except on rails. Floating on ice, so the friction is practically zero. They can head almost directly into the wind, into the apparent wind.
That's amazing.
This is amazing. They can go at 100 miles an hour, almost directly into the wind. And the question is how you can explain it, because if you got the wind pushing on your face, but the direction of your boat is opposite, how does a boat manage to go? It's as though I'm pushing you, but you're going in the opposite direction, and I push you. How does that happen? My next book, please.
Stand by, stay tuned.
Yeah.
There's an implication. Thank you, Gary.
This is my first time using Zoom.
God, we drew you into this world.
For a tech guy, you're kind of buying the times.
See Dr. Pollack, and
Okay, Gary.
Very
Take care.
cool.
Yeah, nice to see you, Gary.
Sail on, brother.
Gary has done an extraordinary experiment where he shrank coins. He's
Yeah,
put some electrical through it and he shrunk coins. So
And
I want to say that there, even I think the ancient ancestors noticed easy water because Steve Thomas,
Oh,
when
yeah.
we first interviewed him about this knowledge, he said, and there's the elder telling me, look in the water. Do you see where it's wetter? The water's wetter. It's smoother. It's wetter. And he said, that's such a hard concept to grasp. But I stared at it long enough, and I'm watching and I'm observing, and suddenly I saw it. Maybe that's easy water.
Could be.
Maybe that's,
Could be.
just a thought.
Yeah.
Anyway, thank you so much. We will let you go, Gerald. I appreciate
Okay,
it.
well, thank you.
Well, this was a wonderful discussion, and we want to thank Dr. Jerry Pollack once again for the fourth phase of water, for all the great work he and his team are doing at the lab at the University of Washington. Keep up the great work there. The implications are so stunning that water, as a crystalline liquid, can hold information, can hold life force and change form. It explains a lot about our experiences and our work and the ancient knowledge of amping up this life force within, how the universe itself, how Earth herself, get out in the sunshine, walk barefoot on the grass, drink pure water, drink lots of water. Just, I think something Joseph said, that chi follows where our intention focuses on, that we can actually activate this through where we place our attention. It's just a beautiful system. We're so happy to be alive in this beautifully designed universe.
And there's more to come with these discussions. This is an ongoing series every Sunday. We've got guests booked way into the future, so please continue to join us. Visit us at our website at QuyamangaInstitute.com. An easier domain name to remember is transpostures.com. That way it will take you to the same place.
Easier to spell.
Exactly. And you can also see our upcoming gatherings for posture work, as well as these discussions, and of course, YouTube and podcasting and all of the rest. So thank you so much for joining us. We hope to see you next time. QuyamangaInstitute.com.